Dear students, in this PPT, let us discuss about the softening of water by ion exchange process, desalination of seawater by reverse osmosis and sewage treatment. Potable water. Water which meets all the parameters of pure water and is fit for drinking, it is called potable water. After removing all the impurities present in water, then it will be fit for drinking, it is called potable water. Desalination is the process of removal of dissolved salts from salt water and water become potable. It is called desalination, removal of salt present in the salt water. The salts present in the salt water can be removed by using some of the methods like reverse osmosis, flash evaporation, electrodialysis, etc. But in your syllabus only reverse osmosis there. We know what is osmosis. When a pure water and salt water are separated by a semi-permeable membrane, the water molecules will move from pure water to salt water through semi-permeable membrane, and this process is called osmosis. The process of movement of solvent molecules, water molecules from pure water to salt water through semi-permeable membrane, and it is because of the difference in chemical potential of salt water and pure water. The movement of water molecules from pure water to salt water takes place until the chemical potential on both either side become equal. Once the chemical potential on either side become equal, then the osmosis process will be stopped. But to remove the salts present in the salt water, we have to reverse the osmosis process. Here in the reverse osmosis, when pure water and salt water are separated by a semi-permeable membrane, and by applying pressure on salt water side, then the water molecules from salt water will move towards pure water. It is called reverse osmosis. So by applying pressure on the salt water side, we can make the water molecules move from salt water to pure water through a semi-permeable membrane. This process is called reverse osmosis. This reverse osmosis unit consists of a vessel, high pressure pump and a semi-permeable membrane. So with the help of piston or high pressure pump, when a pressure in the range 410 to 540 psi is applied on the salt water side, the water molecules will move through the semi-permeable membrane and we can get pure water. The water containing these salts will be drained out. So like this, by using this reverse osmosis process, we can get water molecules from salt water. We can remove the salts present in the salt water. Softening of water by ion exchange process. So ion exchange process is an important advantageous method for the removal of hardness causing ions such as calcium and magnesium ions. Normally the hardness of water is due to the presence of salts of calcium and magnesium. Chlorides, sulfates and bicarbonates of calcium and magnesium. Normally these salts they causes hardness in the water sample. The ion exchange unit, it consists of cation and anion exchange resins which are made of cross-linked polymers with porous structure and desirable functional groups. The cation exchange resin is made of styrene divinyl benzene copolymer with sulfonic acid functional group containing replaceable H plus ions. It can be represented as RH plus, where R indicates the polymer chain, copolymer chain. So, and there will be a number of replaceable H plus ions will be there. This is cation exchange resin. Similarly, the anion exchange resin is made of styrene divinyl benzene copolymer with basic quaternary ammonium functional groups containing replaceable OH minus ions. It can be represented as ROH minus, where R that represents the copolymer chain. So this is anion exchange resin and this one is cation exchange resin. So this ion exchange unit that consists of both cation exchange resin and anion exchange resin. process. Cation and anion exchange resins are packed in separate columns as shown in the diagram. Look at this diagram. The first column is fitted with cation exchange resin and the second column is fitted with anion exchange resin. The hard water containing the salts of calcium and magnesium, calcium ions, magnesium ions, and also the anions like sulfate ions and chloride ions. At this stage, the water contains all both cations and anions. When water is first passed through this column containing cation exchange resin, all the cations present in the water sample like calcium and magnesium ions, they will get exchanged with H plus ions present in the resin. See this equation RH plus, there are H plus ions in the resin and M2 plus, where M indicates the metal ion, M2 plus ions they are present in the water. When water is passed through this membrane, so cations of the water they will get exchanged with H plus of this cation exchange resin. So as a result, so here at this stage there will be no more cations, but still there will be anions like sulfate and chloride ions, and since there is an equal number of H plus ions released into the water, at this stage water is more acidic. So at this stage water contains plenty of H plus and anions like sulfate ions and chloride ions. Then this water is passed through the second column fitted with anion exchange resin. When water passes through this resin, the anions like sulfate and chloride they will get exchanged with the OH minus ions present in the resin. Equal number of OH will be released into the water and they will get neutralized by H plus ions. See this reaction. ROH, it is the resin. So X minus the anion, monovalent anion present in the water sample, there is no reaction, only it is exchange. Therefore it is called ion exchange method process. So X minus, it will be exchanged with the H plus giving RX minus and OH minus. If the anion is divalent like X2 minus, it will exchange with OH minus giving R2 X2 minus and 2 OH minus. See, like this we can remove both cations and anions present in the water sample, hard water sample. So at this stage, at the end, we can get soft water which is free from both the cations and anions. On prolonged usage, the resins become deactivated. Both the cation exchange resin and anion exchange resin, they will become deactivated. They need to be recharged. This process is called regeneration. Cation exchange resin should be regenerated, treated with HCl. See, this is the deactivated cation exchange resin. The resin contains these cations. So when this deactivated cation treated with HCl, H plus ions, so again there will be replacement of exchange of ions. So the H plus ions will stick to the membrane and M2 metal ions will be washed out, drained out. Similarly, the deactivated anion exchange resin, so will be treated with base sodium hydroxide. So there will be exchange of OH minus ions and anions. So again the resin will be regenerated, ROH minus and RH plus, and this process is called regeneration process. The columns finally washed with distilled water before usage. What are the advantages of ion exchange method? It can be used for high pressure boilers also. In the boilers to feed the boilers with the pure water, so we can use this ion exchange method to remove the salt, dissolved salts present in the water. Water of 1 to 2 ppm purity can be obtained from this process. It can be regenerated and used for long period of time. With this regeneration process, the ion exchange unit can be used for long period of time. But there are some drawbacks, disadvantages. What are these disadvantages? It is expensive. So installation of this one, it takes is more cost, it is expensive. Iron, manganese cannot be removed as they form complexes with resins, cannot be used for turbid waters. Water pollution. Water pollution means it can be defined as the discharge of foreign substances into water that affects the physical, biological and chemical properties of water, which in turn decreases the utility of water, is known as water pollution. The matter which is responsible for these unhealthy changes in water is known as water pollutant, like heavy metal ions or acids or alkalis or pesticides or insecticides, fungicides, etc. Depending upon the sources of water pollutants, sewage water can be classified into two types. One is the domestic sewage and the other one is industrial sewage. Domestic sewage is the waste discharging away from residences, institutes, hospitals, etc. These include certain organic waste, pathogenic bacteria, plant material, pesticides, detergents, etc. Domestic sewage causes waterborne diseases like dysentery, cholera, typhoid, etc. Industrial sewage, it is the waste released by industries. It contains heavy metal ions like lead, calcium, etc. Acids, they contain alkalis, pesticides, detergents, insecticides, fungicides, soap, etc. It can be rendered harmless by suitable treatments. The organic waste present in water undergo degradation and break down into simple molecules by bacteria. So this is about domestic sewage and industrial sewage. See, the waste from domestics or industries, industrial waste and domestic waste, before dumping into the nature, we have to remove the impurities present in both domestic and industrial sewage. To do this one, so sewage treatment process will be done. We have to carry out the sewage treatment. This is the process of removal of contaminants present in the sewage, in both the domestic sewage and industrial sewage, and this process is called sewage treatment. It contains three stages: primary treatment, secondary treatment and tertiary treatment. Let us see one by one. In the primary treatment, it is the process of removal of coarse, floating, suspended impurities. So look at this diagram. When the water sample, the sewage containing floating, suspended and coarse impurities, first it is made to pass through the grids or screens. When the water is passed through these screens or grids, any coarse materials or floating materials can be removed. Then the water will be taken into sand filter beds. When it is passed through the tank containing a sand filter bed, the suspended impurities can be removed and then it will be taken into large sedimentation tanks for coagulation and sedimentation. Sedimentation is the process of removing suspended impurities by allowing the water to stay undisturbed for some time in a larger tank. If the water is allowed in the tank for some time without disturbing, the suspended impurities present in the water, they will collected at the bottom of the tank. Then still, if the water sample containing any colloidal impurities, colloidal particles, they can be removed by the addition of coagulating agents or precipitating agents like potash alum. So when we add this coagulating agent to the water sample containing colloidal impurities, the size is very small, then the colloidal impurities size will be grown bigger and the impurities will collect at the bottom. It will be free from the suspended impurities and colloidal impurities. Like this, in the primary treatment, we can remove the floating impurities, coarse impurities, suspended impurities, colloidal impurities in the water sample. This is called primary treatment. Primary treatment, then the water will be taken into the large tanks. For secondary treatment, it is called activated sludge process. If the water sample contain the organic impurities, biologically oxidizable impurities, they are not possible to remove in the primary process, will be taken into the secondary treatment. Here in the secondary treatment, the primary effluent will be taken in the large tanks and to which activated sludge containing microorganisms will be sprayed over the water and oxygen will be blown. When oxygen is passed vigorously, the microorganism present in the activated sludge, they will oxidize the organic impurities into carbon dioxide and water due to aerobic oxidation. Then there will be sludge is formed and residual water, secondary effluent, is treated with chlorine or UV radiations to kill bacteria. Then the water will be, the secondary effluent will be taken into tertiary process. In the tertiary process treatment, if this water sample still contains the heavy metal ions, colloidal impurities, still if they are there, non-degradable organic matter, they can be removed effectively in the tertiary treatment. The removal of phosphate as insoluble calcium phosphate can be done by treating with lime. If there are the phosphate ions in the water sample, they can remove by treating the water with calcium hydroxide. When we add calcium hydroxide to the water sample containing phosphate, it will be converted into stable calcium phosphate. If there are heavy metal ions in the water sample, they can be removed by converting them as insoluble sulfide by the addition of sulfate ions. The heavy metal ions like lead ion, mercury, cadmium, to these ions when we add sulfide in the form of H2S, so the heavy metal ions, they will convert it into their respective sulfides. So it will settle at the bottom. We can remove heavy metal ions also. The removal of remaining organic matter by adding activated sludge. Then to the water add activated charcoal. There will be minute pore structure in the activated charcoal. So the remaining organic matter will get absorbed through the porous structure of activated charcoal. So the organic matter can also be removed. Non-degradable organic matter, if they are there in the water sample, they can be removed by adding activated charcoal to the water. The removal of remaining colloidal, if still there are any colloidal impurities present in the water sample, in the tertiary treatment, they can be removed by adding alum, potash alum. So like this, in the tertiary treatment, so we can remove the phosphate ions, heavy metal ions, non-degradable organic matter, and if still any colloidal impurities are there, they can be removed in the tertiary treatment. So like this, the sewage, industrial sewage and domestic sewage can be treated by this primary, secondary, tertiary treatment and can be removed the impurities present in the water sample. Thank you.